Hello and welcome everyone to this video where I will be explaining my first machine learning end-to-end project on a regression dataset. So let's start. So I got this dataset from using Kaggle.com using this link, and basically this is the problem statement. The problem statement says that there is this health insurance company which wants to create an automated system which will estimate or give the prediction about the annual medical expenditure for new customers from the data set that they already have. Okay, and so let me first show you that what product I have built according to this problem statement. I have built this app which is called a health insurance app. So here is the 4 pages you will get inside this app. So first page is the home page. This is the home page, and the second one is the prediction page, which was the main requirement of the company. They want that the user will give input above for these features like age, sex, BMI, number of children they have, smoker, and region, and then the app will be able to predict the yearly medical expenditure. Okay, and the third feature of this app will be contribute, where the user, if he or she wants to contribute to the dataset by giving their inputs, that they will fill this form and also fill the charges that they had to pay. Okay, and submit, so that after submission the this dataset will be included to the dataset of the company. And the insight page, fourth one is the insight page. As you can see here, the company also wanted what is they wanted to know the reason that why the app is showing this type of prediction. So these are the insights, main insights actually. These are the main insights or main details why the prediction is coming this way, or some whatever the number it will show. Okay, so, so now if I would like to divide the life cycle of this project, then I would like to divide it in 4 steps. First step will be the exploratory data analysis step. Second will be the model building. Third will be the app building, and fourth will be the deployment on the Heroku. Okay, so let's start. This is the here from here the first I am importing my required data sets. Sorry, required libraries that I will use. Then this is my data set, and the basic functions to know the information about the data set, the shape information. Then is there any null values or not? And then the basic description about the statistics of the data set, mainly about the numerical columns of the data set. Okay, then now from here I'm starting the EDA part. In this step, I'm actually trying to understand the data set and what are the factors and features which are having high impact or low impact on the dependent column. Basically, I'm trying to find out the correlation between the independent and dependent columns. So one by one, I will try to check up on all the columns, and you can see here I have only 6 columns, 6 independent columns and 1 dependent column. So first on the age column, I have done if I want to see the histogram of the age column, I can see this and say that age columns follow mostly a uniform distribution, except under the age of 20. I'm seeing here 2 high peaks here. Okay, and there are no outliers. If I see here in this blocks plot, I see no outliers here. In when I am checking on the BMI column, it follows a Gaussian distribution, not actually Gaussian, but it seems like a Gaussian distribution, which is centered around this peak. You can see around the BMI of 30. Okay, actually the BMI score, if you see from 25 to 39 is considered as overweight and obese. Okay, so we can see that according to this histogram, you can see the maximum is between 25 to 40 or 39. I can say the more number of values are present inside this 25 to 40 range. I can say that according to the lifestyle of people are these days. That is the main reason that people this distribution is like this actually. Okay, then I wanted to when I'm trying to see the box plot of BMI, I can see some outliers present here. Okay, some outliers present here. So see this at this point outlier. So I should do outlier handling. But so outlier handling should be done in according to the use case. Okay, so I had to check here, is this BMI column putting some impact on my charges column or not? Okay, so here I saw that the BMI column has some correlation with the charges column, that is my dependent feature. So I had to, but still I cannot just drop all the outliers, because these observations can be useful for the company. They can gain some knowledge about why and what is the reason of these outliers. So this will be helpful for the company. So that's why I'm not directly dropping those columns. Okay. Then when I saw the charges column, there are also some outliers here, but since it was affecting a little bit, it affecting my prediction a little bit. So what I did here is I decided to just cut down the extreme values. Okay, the extreme values, not all these numbers, not all these observations, but the extreme values. So when I used this condition, so I got these 5 rows only. These 5 rows were very much extreme values. So I decided to drop only these 5 rows. Okay, where the BMI was greater than 45. Actually, this is the formula of BMI. So when I try to check if someone is here, here the higher fence is more than 45. Okay, so when I try to calculate according to this formula of BMI. So if someone is having more than 45 BMI, and I've taken this 1.7 meters, I've took an average of 1.7 meter square of height of generally a person. So if someone is having 45 BMI, then their weight will be something around 120 to 130. So it is rare to see someone 130 kilos. But still, I did not want to drop all these outliers, but I just decided to drop only these 5 columns, which were really extreme values. Okay. Then I try to check the relationship between the smoking column and charges column. So here I saw that smokers are generally paying more money towards medical expenditure. Okay. Then the BMI column and the charges column. This is a very interesting plot here. You can see that BMI ranging from 30 to 40, there is a huge cluster here. Okay, these orange dots are people who are not smoker, but this blue ones are the people who are smoker, and you can see a little bit of linear relationship. Okay, uh, so uh, so it says that people who have BMI between 30 to 40 actually pay more towards the yearly medical expenditure. And if you are someone who is a smoker, you will eventually end up with greater greater BMI score. Okay, and also will be have to pay. You will have to pay a greater amount of money for the medical expenditure. Okay, then the smoker and BMI column. Uh, so here it is the when I try to check the median, it was the median was same for smokers and non-smokers, and then I checked sex and BMI, sex and BMI. Then this was mean. This was the mean for sex and BMI. This was also around the same. And then I tried to check sex and charges column. So what I saw here is a person's BMI can be high irrespective of smoking habit or their sex. Okay. So then coming to male or female. So on an average, males have to pay a little bit more towards the medical expenditure. Okay. So then the age and charges column. This is also an interesting plot that we are seeing here. This is between the charges, age, and smoker features. So yearly medical charges are increases gradually with age, but with the variation. You can see here there are 3 clusters. I can say this one first cluster, second one. This is the third cluster. Okay, so we can see here it varies with age. Okay, expenditure, the charges varies with age. But if you are a smoker, you will have to pay more. But if you are a non-smoker, you will have a little bit less expenditure. Okay. Uh, so then regional charges column, actually there is no such significant correlation between these 2 columns, and because this southeast bar is little bit high, because I think there the number is here you can see 360. Okay, So then I try to find out the correlation between the columns, and from this I can say that age column and BMI column, actually these are the numerical columns. So age column and the BMI column have more correlation with the charges column than the children number of children column. Okay. Then I try to check the correlation of the smoker column with the charges column. I saw that it is showing me 0.78. So smoker column has the most correlation with the charges column, my dependent feature. Okay. So so this was my EDA part. So in this part, I got to know that that smoker column was had more correlation with the my dependent feature. Then comes age, then comes BMI. Okay. Then I am here. I'm just doing my X and Y split. Then I did train and test split, and then then here from here I'm starting my model building. Okay. So some steps I have not shown here. Actually, I did feature scaling and feature scaling also. But at last, when I saw that I have used these algorithms, but the random forest algorithm was giving me better prediction. So that's why so there is a fact that uh, feature scaling does not put that much impact on when we are using random forest. That's why I decided to drop that. So and then what I did here is I tried to convert this region column into numerical. I had done one hot encoding on this region column, uh, but what happened is the when I tried to build the app, uh, trying to do it with the one hot encoded some extra columns. When it created 3 extra columns, and it was a little bit lengthy process. To build the app, so I decided to do the labeling instead. First of all, I try to label it with the frequency of that column. You can see, yes, I decided to do the frequency encoding with these numbers, but you can see southwest and northeast have same number. So it will give me problems. So that's why I decided to uh, use this dictionary mapping method. So then I tried model building. You see, I used these algorithms, and I had also used grid search CV for hyperparameter tuning, and those parameters which I got as a result, I used those parameters to uh, find my prediction to do the model building actually. Okay, so and for metrics, the performance metrics, I used R2 score, mean absolute error. Actually, there are a lot of performance metrics like R2 score, mean absolute error, mean squared error, root mean squared error, and adjusted R2 score. But as we know that every performance metrics has its own advantages and disadvantages. So I had to select which metrics will be best for this project. So I had used everything and saw what result it is giving me. Then I selected these two, R2 score and mean absolute error. Okay. So when I completed the model building, I saw that random forest was giving me the uh, best R2 score and best mean absolute error. Okay. Um, so you can see here SBR has given me a negative number as R2 score because after dropping the feature scaling part, it gave me this bad R2 score because as we know that SVR, KNN, regression, linear regression, and all, they have they use distance calculation of distance as their part of their algorithm. So that's why this scores are too bad here actually. But it didn't put any significant impact on random forest. It was showing around 0.88 or 89, and it reduced a little bit to 0.86. Okay, and I also used adjusted R2 score just to see that I can rely on this R2 score or not. So it was giving me around the same number only. I can say that adjusted R2 score is little bit reliable than R2 score because of this formula only. This formula is little bit different. And here what I'm doing is I'm exporting the model using this pickle. Uh, Here what I'm doing is I'm just storing the knowledge that my uh, model has created, and model has now my model is trained, and the whole knowledge is stored here, here, and here. Okay, I'm creating two files. First one is of df, my data frame. Second is my model, random forest. Okay, so my two parts are over now. Then I will jump to the third part, which is app building. App building I have done from with PyCharm. First of all, I have used Streamlit. Okay, it's an open source Python library which makes it easy actually to create beautiful apps. Uh, it is an inbuilt Python library only. And another way of doing this was uh, using Flask and HTML. That was you can also use that. I will use Flask and HTML in my further next projects. I use this because it was at the only one place I can do my HTML and uh, the work of the Flask. So that's why it is a little bit easy. So that's why I have used Streamlit here. Okay. So here what I'm doing is I am importing the model that I have created there. And so for creating the navigation or the four options that I had, I am coding like this. Okay. So if the user tries to see the prediction, it will go into this if and else code, and gradually it will move like this, the code. Okay, you can see that I have only used 88 rows of code and created the app using Streamlit. Okay, and to deploy I had to create these files. Okay, for without these files you cannot deploy this on Heroku. Okay, so and yes, this is the expenditure.csv. I have created this because if someone wants to contribute to our dataset, it will be stored here in this CSV file. Okay, so then the next part is the fourth part is the Heroku deployment. Then you can see I have done the Heroku deployment using my GitHub. Here you can see the deployment is active, and if you yes, you can see the app from here. Okay, so this is the link. This is the link of the app, and this is the app. So if some user, suppose I'm a user and I will give some inputs like 27 male, BMI, suppose I will give 28, number of children, give 0, smoker yes, and the region, whatever region according to the company, suppose Southeast. If I try to see, yes, the predicted annual health expenditure is $18,100. Okay, this is the number that the company wants to know. And as we saw here, the mean absolute error was around 2540. Okay, this is the error that I'm getting. This was the lowest error that I got from all the algorithms. And the insights that the company wanted to know: people who smoke and have BMI above 25 have high chances. Okay, oh, so little bit spelling error, from suffering different diseases and consequently have more annual medical expenditure. Male tend to have slightly more annual medical expenditure in comparison to female. People who smoke and are older than 35 years of age have high chances of suffering from different diseases and consequently have more annual expenditure. So these are main factors which are which put an impact on the expenditure. Okay, so this was all about this project. Further, I will try to create more projects which will be a little bit more challenging than this, as this was my first project. So I decided to keep it simple. So thank you for your valuable time. Thank you.